For the next couple days, we're going to be working on a topic known as linear programming. And one of the ideas behind linear programming is we're going to use systems of inequalities, like we were working with today, to look at how to apply them to some real world problems. So you'll see a lot of word problems in the next couple days. Today, we're just going to be working on looking at these things graphically and figuring out how do I graph this and find the information that I need. Then we'll start working on putting it from a word problem into a graph. So the history of linear programming was actually developed during World War II in the 1940s as a way to help them with their planning when they were sending different pieces of equipment in all kinds of different places. So they had lots of scheduling they had to worry about. So they used linear programming to help with that. One of the things that you use linear programming to do is to optimize things, like find maximums and minimums. So we might be looking for a business problem where we would maximize profit or minimize cost. Or we could be looking at an application problem where you'll do those of you taking calculus, you'll talk about trying to find the maximum volume of a container when you're using the minimum amount of material. And here are some different places you might see linear programming used. You might see it with airlines when they are scheduling flights, in telecommunications where you have a lot of moving parts and things going on, stock markets, and all kinds of different places. So let's look at this application problem. We have a farmer that wants to plant wheat and rye. So we have two different crops here. And he has to plant at least 7 acres. So just kind of highlighting important numbers here. However, he has only $1,200 to spend, and each acre of wheat costs $200, and each acre of rye costs $100. Also, he has to get all of his planting done in 12 hours, and it takes 1 hour to plant an acre of wheat and 2 hours to plant an acre of rye. Then he has a profit of $500 for every acre of wheat and $300 for every acre of rye. So what I want to know is how many acres of each one should he plant so that he can maximize his profit. So to help me organize this a little better, I'm going to take a table and I'm going to fill in all the information that I know. So I know I have 2 crops, wheat and rye, and I'm going to call wheat the X variable and rye is going to be the Y variable. Then I know how much it costs to plant each of these. It costs $200 to plant the wheat and $100 for each acre of rye. And then it takes 1 hour for wheat and 2 hours for rye. And then my profit is $500 for my wheat and $300 for my rye. Now, I also know some totals here. So if I look, the first thing they told me is that he has to plant at least 7 acres. So I'm going to let X and Y represent the number of acres of each one of those different crops. So then if I take X plus Y, it has to be at least 7. So that means that I want it to be greater than or equal to 7. Now, remember that I have a total of $1,200 to spend on planting, and I have 12 hours that I can spend on planting. And then what I want to do is I want to try to find the maximum of my profit. Now what I want to do is I want to make some inequalities that are going to represent everything that's going on in this problem. So I'll come back to the objective function in just a minute. We're going to look at the constraints. So remember, we had one of the constraints already, that X plus Y had to be greater than or equal to 7. We also knew that the total that I could spend on planting was $1,200. So if I take 200X, that's how much it costs, $200 for wheat, plus 100Y, then that has to be less than or equal to $1,200 because I can't spend more than $1,200. And then my hours, I had 1 hour for wheat, so 1X, and 2 hours for rye, so plus 2Y, and I can't use more than 12 hours of time, would be less than or equal to 12. Then there's 2 kind of understood constraints So these are kind of restrictions on my problem. X has to be greater than or equal to 0 because X is the number of acres of wheat. Well, I have to have either 0 or more acres of wheat. And then Y has to also be greater than or equal to 0 because Y was the amount of rye that I was going to plant. So it has to stay greater than or equal to 0. Then the objective function is what I want to maximize or minimize. Well, remember, we're trying to maximize my profit. Well, we make $500 for each acre of wheat. So if I do 500x plus I make $300 for rye, so that would be 300y. That's my equation that I'm going to use for profit, and that is going to be my objective function. Now, on the problems that you're going to be working on, those equations or inequalities are going to be given to you. So for today, you're just going to work on the graphing. So don't worry about trying to set up the problems. We'll look at more of those as we go along. So let's look at our inequalities again. So we had x plus y was greater than or equal to 7. So if I plot that, notice that the axis is just in quadrant 1 because we had these restrictions that x was going to be greater than or equal to 0 and y was going to be greater than or equal to 0. So that would keep everything in quadrant 1. If I solve, I would have y equals negative x plus 7. So if I plot that, and you do need to be very careful about plotting because these graphs have to be really accurate. So then we're going to go down 1 over 1, and then this was a greater than or equal to. So it'll be a solid line. So then I would shade everything that was above that line because it was greater than or equal to. So I want everything on this side of the line. Now my next inequality was 200x plus 100y was less than or equal to 1200. Well, if I solve for y, I get y is less than or equal to negative 2x plus 12. So now let's plot that. So we're going to start up at 12. I'm going to switch colors. So we'll start at 12, and my slope is negative 2. Notice again, I'm being very careful about graphing this because these points where these graphs meet and the points where we touch the x and y axis are really important. So then I will connect that with a solid line, and we were less than or equal to that. So that's going to shade everything that would be below that line. And then we had the inequality that x plus 2y was less than or equal to 12, which means y is less than or equal to negative 1/2 x plus 6. So let's plot that. I'm going to switch colors. So we're going to start at 6, and our slope is negative 1/2. And we want everything less than or equal to that, which would be here. Now we also have the restriction that I have to stay in quadrant 1 because x was greater than 0 and y was greater than or equal to 0. So then that means my graph is going to be everything here in quadrant 1. So here's what happens. The part of this that got shaded 3 times is this triangle area right here. So I'm going to kind of pull that off, and then I want to look at those ordered pairs. So let me give you a little bit of terminology. The part where all of this meets and is shaded is called the feasible region. So in your directions, you're going to be told to find the endpoints or the vertices of the feasible region. So that's the part where all of this overlaps. So I'm just going to kind of pull that triangle out. It looks something like this. And I'm going to go ahead and write the ordered pairs because the vertices are really the important part to this. So if I look, right here's one of the vertices, which is at 2 and 5. So this is the point 2, 5. Then this point is one of the vertices, and that is at 4, 4. And then the last vertex is right here, and that is over at 5, 2. So again, the graphing is really important because I have to have all these points. You'll see in just a minute that these are the points that I'm going to use to help me figure out where the maximum or minimum occurs. So in linear programming, once you find the feasible region, then one of those ordered pairs, or at least one of those ordered pairs, will be your point that's your maximum or minimum. So once I've found the ordered pairs, then what I'm going to do is I'm going to make a table, and I'm going to find my maximum and minimum for this. In this case, I actually just need to find the maximum because I'm trying to maximize my profit. Well, remember, your profit equation was 500x, because you made $500 off of wheat, plus 300 Y. $300 for the rye. So I'm going to take my corners, that's my vertex for the three vertices of the triangle, and those are going to be my possible maxes and mins. So once I get those points, I now substitute them in to my profit equation. So if I put the 0.25 in there, I'm going to get $2,500. If I put the 0.44 in there, I get $3,200. And if I put the 0.52 in there, I get $3,100. So I'm looking for the maximum, which is going to occur right there. So you want to plant 4 acres of wheat and 4 acres of rye, and that will give you a profit of $3,200. So we're going to wrap up by doing a problem like what you're going to be asked to do in the assignment, so you can kind of see you're not going to really be working on word problems. We've got our constraints are the equation 2x plus 3y, or the inequality. 2x plus 3y is greater than or equal to 6. So I'm going to start and go ahead and let's solve that for y. And if you do, you're going to get y is greater than or equal to 2/3 x plus 2. Let's go ahead, actually it's negative 2/3 x plus 2. And let's go ahead and graph that. So we're going to start here at 2, and then our slope will be down 2 over 3, and we're going to get that point. And remember, because we have these constraints, that x is greater than 0 and y is greater than or equal to 0, that's going to keep everything in the first quadrant. So there is my first line. All right, now let's look at the next one. So we have 3x minus 2y, and I'm going to switch colors here, is less than or equal to 9. If I solve that, I'm going to get y is greater than or equal to 3/2 x minus 4.5. So we'll plot that. So we're going to start at 4.5. Normally, we wouldn't have to go down on the y-axis, but since our y-intercept this time is at negative 4.5, we're going to go down 4.5. It's going to put me right about here. And then my slope is going to be up 3 over 2. So I'm going to do that a couple times. And then I'm going to connect that, and that's going to give me that line. And I actually forgot to go back and shade. So let's go back. On the first line, we wanted to shade everything above the red line. So that's going to put me here. On the blue line, it's a greater than or equal to. So that's going to shade everything above the blue line, which will put me in here. And then my last line, if I solve for y equals, or y as an inequality, I would get y is less than negative 1/5 x plus 4. So that's going to start me at 4. And then my slope is going to go down 1 over 5. And that's going to give me this line. And I was less than or equal to that line, so that gives me this. So what I'm looking for, and I'm going to kind of highlight this in black, is actually this quadrilateral right here. That's the part that got shaded by all those different colors. And what I need, and I'll pull that out, is those ordered pairs that are at those vertices. So at the bottom here, if I look, I'm going to have the point 0, 2. This point is at 0, 4. Down here is the point 3, 0. And then my last corner right here. It's actually here. And that is the point 5.3. And now that I know my 4 points, I'm going to just substitute those into my objective equation, and I'll find my maximum and minimum. So I'm just going to be up above the points. I'm going to put the values that I get when I substitute into the objective equation. So if I put in 0, 4 into x plus 6y, I'm going to get 24. If I didn't put in the point 5.3, I get 23. If I put in the point 0.2, I get 12. And if I put in the point 30, I get 3. So now I can look at those, and what was my maximum value? Well, my maximum was 24. That was the largest number I got. And my minimum value was 3. So that's the kind of problems you're going to work on. All of the inequalities and the objective equation will be given to you. You're really just focusing on getting the inequalities graphed and finding the point where they're going to overlap.